last meeting, we discussed up to leveling datum in mean sea level. So now let's just continue on with our lecture. So the next topic is effects of curvature and refraction. So this is still under the correction aspect of leveling. Previously, your mean sea level isn't much of a correction, more on standardization. So you want to take or you want to convert readings above a certain level or at a certain height into what it would be if it was taken at sea level. Okay. So now let's talk about the other effect for leveling, which is the effect of curvature and refraction. So let's say we have this instrument, your precise level or theodolite, and we have placed it on the surface of the Earth. As we know, Earth isn't flat, right? We know this. And then because of that, because of the curvature of the Earth, what we read isn't actually horizontal. So look at this diagram. So for example, this is your instrument. Okay. This is your line of sight, right? And then that's not how or the height of the instrument should be along the height of or the height of the point should be along the height of your instrument. So this should be the actual reading. Okay. So this correction is due to the effect of curvature. Okay. So if we were to draw a horizontal line from your line of sight or from this instrument, it's this dashed line here. Okay. Again, that's not the correct reading because of the curvature of the Earth. It should be over here. So that's effect of curvature. Another thing that we have is correction due to refraction. So in your previous physics classes, you might have heard of refraction, right? It bends light. So same way it bends your line of sight. So again, it should be horizontal. Because of refraction, it turns here. Okay? So all in all, total correction is your C plus R. Once again, this total length, the larger length, is effect due to curvature, and then it's decreased because your line of sight is already bent downward because of refraction. So this is your C plus R. Okay, so now let's have your formal definitions. Or error due to curvature, we call that H sub C. It is in cases of long distances, the horizontal line and level line do not coincide. Remember, level line is the line that is perpendicular to all points on a vertical line. Okay? So in short, it just follows the curvature of the Earth. Level line isn't absolutely horizontal. Okay? So that's why they don't coincide, because it curves. So this means the vertical distance of an object from the level line is going to be larger than the distance which we calculate from the horizontal line. So to make or to account for that correction, H sub C is 0.0785 k squared. Later on, I'll tell you what that k is. Next, our error due to refraction. So that's your H sub R. So light rays passing through the Earth's atmosphere are bent or refracted towards the Earth's surface. This means that the line of sight from the instrument will be lower than the horizontal line. Okay, and then again, the correction for that is 0.011 k squared. So HC, correction due to curvature in meters, HR, correction in refraction in meters, and K is level distance in kilometers. So please take note of these units. These are the units that we should use when using this equation. Therefore, total correction is just HCR equals HC minus HR. So this is the only equation that you need to remember, 0.067 k squared. Okay, so that's already the total correction due to curvature and refraction. All right, so now taking that into consideration, again, this is just our equation. Let's have a few examples. Okay, example 2. An observer standing on a shoreline of a lake can just see the top of a tower on an island. If the eye of the observer is 1.655 meters above the lake, or above the lake level, and the top of the tower is 15.22 meters above lake level, how far is the tower from the observer? So we're given heights for line of sight. What we need is distance between them. And distance is just your K. Okay? So again, K, level distance in kilometers. So for us to better understand, let's try to draw that problem. So please ready your calculators. So let's try drawing that. Again, we're exaggerating the curved surface. Something like this. Okay, and then, okay. Okay. Okay, yeah. So let's say your human or whoever's looking is over here. Okay. Let's just use a stick person for now. And then this is that person's line of sight. And the only thing that this person sees is the top of the tower. Okay. So let's say this is our tower. Very rough sketch of a tower. Right? So the question is, what is this total distance? Level distance. So level distance again meaning following the curvature of the earth. So to get that, it's not just this, okay? Like you're gonna compute this. No. What you're gonna do, since this line of sight hits this, that is where it stops. Okay. So it's gonna look something like this. This is the first distance. Okay. And then this is the second. Okay. And then what we're gonna do is we're gonna treat it as if this is where our instrument is. Okay. And this is its line of sight. Okay. So therefore, if this is where your instrument is, looking here, this is the correction due to curvature, and this is the distance between your instrument and that height. Okay? So meaning that's just adding K1 plus K2. Okay? So let's do that. Once again, since this is the curvature of the Earth, therefore, if we place an instrument directly here, its height or its level should read somewhere on this point as well. But no, this is where this is where the line of sight is. So when you go there, this is the correction. This is your HCR for this person. And then same thing here, this is the HCR for this tower. Okay? So let me write that as well. So once again, HCR, let's call that HCR1. And I'll move this as well. HCR1. Same thing here, this tower, HCR2. Okay, so now let's use, again, the goal here is to look for K1 and K2. So HCR1, okay, is given. That was 1.655. And that was the eye level of your person. And then HCR2 is the height of your tower. And the height of the tower is 15.22 meters. Okay? And then remember, the equation for K, for the correction, is 0.067. Okay. So therefore, if we're looking for total K, KT is the total distance between 2 points along the level surface. That's K1 plus K2. And again, HCR, our basic equation, HCR equals 0.067 K. Therefore, K, is this K or K squared? Oh, let's double check. K squared. Okay. Therefore, K is just square root of HCR over 0.067. So let's write that here. Okay. HCR1 for K1 over 0.067. And then plus HCR2 over 0.067. Okay, considering HCR1 1.655, HCR2 15.22, what's our answer? Correct. Correct, Michael and John. Acido phosphide. Okay, it's 20.04. What's the unit? Correct. Very good. So it's kilometers. So correct again, John and Penoliar Zaira. Penoliar. There we go. Kilometers. Why? Well, again, remember, uh, K is in kilometers. So if we solve for K, the resulting answer would be in kilometers as well. Okay. And then all of our units here are in meters, so that's why we can just plug it in without conversion. Okay, so this is our answer. Okay. Any questions for number 1? Please answer in the chat, clear or none, or your question. Okay, great. Let's move on to number 2 then. Mhm. Number 2. So number 3 na pala to. Okay, next. Number 3. Point A is in between point B and C. The distances of B and C from point A are 1,000 and 2,000 respectively. Measured from point A, the angle of elevation of B is 18.13 degrees, or 18 degrees 13 minutes, while that of C is phi. Point B is higher than point C, and the difference in elevations of B and C is 44.4. Considering the effects of curvature and refraction, what is that phi? So since we have this, consider the effects of curvature and refraction, this isn't a simple trigo equation or trigo problem, okay? So it's not just we have point C, A, and then B is here, and then this is just solving for phi. No, there's curvature. So let's draw that as well. Once again, we have a curved piece of area. Okay, and then let's do it one by one. A is in between B and C. Okay, B and C 1,000, and B and A 1,000, C and A 2,000. So C is farther from A than B is. And then B is higher than C. Okay, so now keeping all of that in mind. So B, if for example, we choose this as our point A, and point A. B is somewhere over here. And then C is somewhere twice as far as that. Okay. And then it's lower than B. Okay. So these are our points. And then let's just draw a vertical line to that point. Okay. It's also given there that our distances are this. Okay. Again, this is 1,000, 2,000. Okay. What else is given? Let's see. Okay. Elevation of A measured from point A. The angle of elevation of B is 1813. Okay. So that would be this. But it's not from this curved line. That angle of elevation is from a horizontal line. Okay? So this is, let's use a different color. What is that? 1813. Okay. 13 minutes. And then we're looking for phi. And then this is our phi. Okay. So taken from the horizontal line. Okay. And then what are you looking at? So we're looking for phi. And then there's also this difference in elevation is 44. So B is 44.4 meters higher than C. Again, these measurements are taken along our distances or along our Earth's surface. So let's do this. And then I'm gonna make B higher just so that you can see that difference in elevation more. Okay. So B, and then this is the angle of elevation. Okay. And then, yeah. This is the distance or difference in elevation between point B and C, this height. And then this is equal to 44.4. Okay. So this is our complete drawing. So to get C, okay, what we can do is, to get C, what we can do first is get, since we know this distance, okay, all we need is to get this height and then solve trig functions to get phi. Okay, so the drawing isn't that nice. Yeah. Yeah, let's say like that. Okay, so this is that phi. Okay, so to get that, we're gonna need, since we know this distance, all we need is this height. And then let's call that height YC. Okay, same thing here, this height, okay, from the horizontal line, let's call that HB. And then again, because of curvature, we have this correction, your HCRC, or just let's just call it HC. and this is your HB. Okay. So once again, the goal first is to get YC. So to get that, let's compare the left and the right hand sides. Okay, so that would be Y. So HB plus YB, right, equals, and these two lengths are the same now, HC plus YC plus 44.4. So let's get YC, transpose everything. So YC is just HB plus YB minus 44.4 minus HC. Okay. Now we just need to solve for the following. So HB, again, that's just your correction. Okay. So let's get that. 0.067 K squared. And then K is 1,000 meters. Remember, K is in kilometers. So I'll convert that into kilometers. Same thing here. This is 2 kilometers. So that's why this would be 0.067 B times 1 squared, and that's just 0.067, right? Same thing with HC, that's just 0.067, and then K is this, so 2 squared. Please solve, what's this? Correct. Maro and Colleen, Sante, Casople. Okay. 0.268. Okay. Next. Okay, now I need YB, right? YB. How do we get YB? Same thing, and how we get YC, that's using trig functions. Okay, so we will consider this as a right triangle. Okay, we will consider these as right angles. Therefore, you can use your SOHCAHTOA, specifically tangent, because we know this distance. So tangent theta, which is 18 degrees 13 minutes, equals opposite over adjacent. Opposite is your YB, which is what I want to get. Adjacent is this. So our measurements are in meters, right? Your HC, HB. So I'm going to use the measurement in meters for the distance between the points as well. Then from this, please solve what's YB. Correct, Michael and Raymar, Bernardo Acedo. It's 329.11. And then, not there. And then again, if it's not a whole number or it's not just 2 to 3 decimal place, you can just store this in your calculator. Okay, so now I have HB, YB, HC. You can compute what's YC. Correct. Gabriel and Zaira. So sampan familiar. So it's 284.50 Once again, store that. And now you can solve for phi. Again, considering this as a right triangle. So phi is just arctangent opposite over adjacent. You already know opposite, your YC, and then adjacent is your 2,000 meters. Please solve what's phi. Correct, Maro and Kian. Kiben Kasopli. Zero point 8.10 degrees. Okay, so that's it for number 3. Do you have any questions? Please answer in the chat. How about the others? Please answer as well. Do you have any questions? Ma'am, doon po sa base ng right triangle sa C, kahit curvature is 2,000. Base triangle sa C? What do you mean same? Yeah. The curvature, the length of the curvature is considered the same as the base, or considering it as a straight line as well, because the difference is very minimal. Yeah, it's the same. So this straight line, okay, considered the same as this length. Okay. And then next, no more questions. Okay. Let's have the next topic. Okay, so that ends this correction part. So the last part for leveling is your two-peg test and your reciprocal leveling. Okay. So two-peg test is the method for checking and recalibrating a level or transit. So for example, okay, usually you want to set up your instrument here. This straight line or this dashed line is the horizontal line of sight, where your sight should be. This straight line shows where the actual line of sight is. So as you can see, there's an error. It's angled upward. Okay? And two-peg test checks what that error is. So you're going to do this. You're going to take elevation between A and B, or difference in elevation between A and B. And then you're going to move this instrument here at A. Okay, and then again, whatever you read here at A will be its actual height, since it's very near. The error for inclination won't be noticeable anymore. And then, you know the difference in elevation between A and B. Then you got the true elevation of A, or true reading here of A. You're going to use that to know what should the actual reading be, your computed foresight here. Okay? And then you'll know the error, because you'll see a different reading. And then you're going to compute what the foresight should be. And then to calibrate this, you're going to rotate it until you see that measurement. Okay, so that's how you check and recalibrate your level. First, to better understand, let's have a few examples. So example number 1 doesn't use this yet, okay? But let's just solve for it for now. So example 1, in the two-peg test method of a dumpy level, the following observations were taken. So first, instrument near A, the rod reading at this position for rod reading at A is 1.505, and then for B, it's 2.054. And then we moved the instrument to B, and then the readings are now 0.938 and 1.449. So question number 1, what is the difference in elevation between A and B? So you want to get the true difference in elevation. Okay, so to get that, let's try drawing first what's happening again. We have example 1, instrument near A. So based on these readings, the point with the higher elevation is actually point A, right? Because if you try to plot this out, okay, instrument near A. So if you draw that, I'll draw it on how it's gonna look like. Okay. And let's say this is your point A, your leveling rod is over here, and then your instrument will be very near A, so that even though it's at an angle, it's gonna take the correct reading. And this reading was said to be a reading on A, 1.505. And then reading at B will be this. So this is the true reading, okay? Here, yeah, this is a true reading. But again, there's an error in calibration. What they read is either upward or downward. So here you're gonna assume is your instrument angled upward or angled downward. So for example, if it's angled downward, then this is where that reading would be. And here, okay, this would be your 2.054. But I'm gonna assume it's upward, so this is that 2.054 reading. Okay. And as you can see, this length is shorter than this length, so this should be the shorter reading. And as you can see, it's at the higher elevation. So that's how you figure out which is at higher elevation. It's usually the one with the smaller reading, because that means and it's higher up, so less portion of it will be measured. Okay, so now let's create an equation out of this. How? Well, if we know the elevation of angle A, so let's say this is the elevation of angle A, and let's call that H. Yeah. And then let's call this correction E. We can say that H plus 1.5, what was that? 505. Okay. H plus 1.505. Okay, this length is equal to this. Okay, so that's equal to 2.05 minus E. 0.54? 0.54, okay. Kulang. And there's nothing to solve for here. So you can just call that equation number 1. So I'm just going to simplify this. I'm going to transpose E to the left. So that would be H plus E equals 2.054 minus that. It's 0.549. And I'm just going to call this equation 1. I have two unknowns here. This means I need another equation for that. And we'll get that by this table. Now the instrument is near B. Okay, so I'll just copy this. Okay. So the instrument near B, the readings would be different. Okay. So let's say it's somewhere here. Yeah. Okay, and then let's see. I want to get the reading here at B. Let me just mark these out. Okay. So this is your A, B, A, B. I want to get reading at B for instrument near B. So rod reading on B, that's 1.449. So this is 1.449. Okay. And then we're gonna get reading at A. Now this is important. The way that your instrument or your assumption for the instrument is inclined should be uniform. For example, if you assume this is upward, you should assume this is upward as well. Okay? And if you assumed it was downward, then you should assume that was downward as well. Okay? So I assumed upward, so I'm gonna do this upward. So this is the actual horizontal line, or it should be its line of sight. Okay. But it inclined upward. And then this reading is your foresight at A. So that's 0.938. And now let's do what we did previously, where we created equations out of this given. So now we can say that this length is equal to this length. Okay, so that is, to get that, I will subtract this. Let's call this your error number 2. Oh, no, it's the same error. So the amount of which this line deviates from the horizontal should be the same, since distance between the points are the same. Okay. So this is a different story if the instruments aren't near your A and B. Okay. So for this situation, this height of error is the same, because again, it's the same distance between A and B for both, or from instrument to A and B for both situations. Okay. So now let's create our equation. So to get this, that's just h plus 0.938 minus error, so minus e. That's how you'll get this height. And then equal to 1.499. So this is your equation 2. Let me rewrite this. Okay. So h minus e equals, I'm just gonna transpose this to the right. What's 1.499 minus 0.938? Correct, Michael. And then bakit 564? 449, my bad. 449. Okay. It's not 499, 449. Correct, Michael and KB. Escobar Asilo. Oh, and then humabo si Mark Villalobos. Okay. 0.511. Okay, and now that's your equation number 2. So equations to unknowns. Okay, what we're looking for is, let's look. Number 1, what is the difference in elevation between A and B? Difference in elevation, that would be the length of this, right? And that's just h. So we'll solve for h. So to do that, I'll use your equations 1 and 2. So h plus e equals 0.549. H minus e, 0.511. So to eliminate e, since I just want h, I'm going to add these two. So we're going to get 2h equals 0.1060. And then to solve for h, at 0.53. Okay, so these are answers, 0.53 in meters. Okay. The number 2, determine the correct rod reading on A with the instrument still set up at B. So what we want to know now is, what is this reading with this setup? Okay, so to do that, you'll just subtract. So this height is 0.938, and then minus your error, right? To get this, because this is the correct reading. and E is no. Okay, let's not do that since we didn't solve for E first. For example, you didn't know what E is. All you know is H. Okay? So to solve for that without knowing for E yet, okay, I know H now, right? So H plus true height of this should equal 1.449. Therefore, to get that reading, that's just 1.449 minus H. Okay? Reading at A. 1.449 minus H. What's the answer? Correct. Correct, Gabriel and Jericho. Sampanda din. Okay? 0.919. And then finally, what we're looking for is error in line of sight. To get error, you can either use equation 1 or 2, up to you. Both will be correct. Let's say we'll use equation 1. H plus E equals 0.549. From this, we solve what's E. Correct, Jasper and Ardiel. So, lapid viernes. Okay. 0.019. Now, there's another way to solve for this. Okay. So using this, you can solve for both H and E. These are simultaneous equations. Okay. So let's say we solve for E first. So you're just going to subtract this and then you're going to solve for E. You'll get this. Okay. So number 3 is done. And then to get rod reading at A, it's what I said before. It will be 0.938 minus E. And you should get the same answer. Okay. So that's number 1. Let's have another example. Okay. Okay. Number 2. So number 1 is just figuring out the correct reading and the error. Number 2 would be portion of it is calibrating. So number 2, the following data were taken from the PEG method of adjustment. So once again, instrument at 1, your readings are A and B. Instrument at 2, your readings on A and B. Now take note, point 1 is midway between A and B. Point 2 is 12 meters to the left of A, 72 meters from B. So it's different from number 1. It's not near your points. It's midway and at a certain distance. So first question, find the true difference in elevation between point A and B. Okay. So once again, to figure this out, let's solve. So looking here, I'll start with instrument at 1. The reading at A is 1. The reading at B is 0. Therefore, again, by analyzing this data, you can say that point A is lower. Point B is at the higher elevation because it's the one with the less reading or lesser reading. So let's draw it that way. Okay. So again, this is with considering B is at the higher level. And then it was mentioned there, your instrument is directly midway. Okay, so it's here. Right. And then the true horizontal reading would be this. Let me just put this downward. Okay. And once again, there's an error in this measurement. So let's assume. Again, you can assume it's pointing upwards or downwards. Okay. I'm gonna assume it's upwards again. Ayan. And then it should be by the same amount, of course. Okay. So for example, I want to take reading on A, it's inclined this way. And then to get reading at B, you're just going to rotate your instrument. And okay. And then the readings are for A 1.103. For B, it's 0.991. Okay. And once again, this is A and B. And then the difference in elevation is just this H. So, since your instrument is directly in the middle, okay, the amount at which, or the height of error is the same. Okay, this length is equal to this length. Again, because it's at the middle. So that means to get H, it's just the difference between the readings. And the answer is 0.112. Okay, pretty easy. So we like it when your instrument is at the center because you can directly solve for difference in elevation. Okay, and that was the first question. Find a true difference in elevation between point A and B. Okay, again, you can't do this if it's not at the center. Now that we know this, let's move on to number 2. Okay, to what rod reading on A and B should the line of sight be adjusted with the instrument still at 2? So now we're gonna draw our instrument at 2. Okay, so let's do that once more. So let me just. So that's still H. Okay, these are H. So now this is your position 1. Position 2, let's see. 2 is 12 meters to the left of A. So to the left of A, somewhere here, this is where your point 2 is. Okay. So let's draw the distances. This is 12 from A. Another is 72 meters from B. So this is your point B. Alright, so to solve, again, let's draw the actual horizontal line. And then remember, what you assume for the first situation should be the same. I assumed it's upwards, so this should be upwards as well. Okay, let's exaggerate it. So, right. So the question here is, to what reading on A and B should the line reading be adjusted with the instrument at 2? So the question is, what should be the reading here? And then I'm going to adjust the instrument until I see those readings. Okay? So let's label all of that. Now, it's pretty obvious. The error on A is not the same as the error on B. Okay, so let's change the names for that. Let's call this now E1. And then this is error 2. Okay? And then we have our readings. Reading on A is 0.568. So apparently this is 0.568. And then 289. Okay, this is okay. So like what we did in the previous question, in order to make an equation, we'll compare the left and the right side. Okay? So we'll compare this to this. So that would be, this is 8. 0.568 minus E sub 1, okay, that's getting this length, is equal to H plus 0.289, that's this total length, minus E2 to get just this. Okay? And then again, let's simplify. I'm just gonna transpose E1 to the right to make it positive and then transpose these two to the left. That would give E1 minus E2 equals, what's 0.568 minus H, which is 0.112 minus 0.289. Correct, John? Minus lang. 0.568 minus 0.112 minus 0.289. Okay. Correct, Jasper. Okay. Yung pinag-gaagayahan yung mali. So 0.167. Okay. There's nothing to solve for there, so I'll just call that equation 1. Let's know what about equation 2. I can create an equation 2 here because E1 and E2 aren't the same. So this is the only drawing I can use to create equation 2. But you've noticed to create equation 2, okay, we actually have two right triangles. This is right triangle 1, this is right triangle 2. Okay. So using similar triangles, we can create our equation. So side 1 equals side 2. Again, I want to use E1 and E2. So this side over this, which is equal to 12, is equal to this over total base, which is 72. Okay, so 72 E1 minus 12 E2 equals 0. And that's your equation 2. I have two equations, two unknowns. I'll leave it up to you how to solve using simultaneous equations. You can use your calculator or do it manually. Okay, please solve what's E1. Let me know, is it positive or negative? I need the value and if it's positive or negative. So correct, John. The actual answer is negative 0.0. Okay, may humabol. Correct, RDL and Geraldine. Zero lapit. Okay, negative 0.0. So these are the answers for E1 and E2. As you've noticed, they're negative. So when you get a negative answer, that just means your assumption is incorrect. So in actual, okay, your rod is not actually upwards, it's downwards. Okay, so if you have this, if this is the horizontal line, your line of sight is like this. Okay, and so therefore that just means your instrument was rotated downward. And then using this equation, okay, that means to get the true reading, okay, for example, so let's try correcting our drawing. And so for example, if this is your reading at 1, this is 2. Okay. And if this is your reading at 1, this is actually your 0.568. So reading at A, okay, is actually 0.568 plus E1, okay? Because that's the correct orientation now. And the answer is 0.601, okay? And then reading at B, so same thing, this is your B, this is your E2, this is your reading at 2, that was 0.289. So to get the correct reading, which is following the horizontal line, again, that's just 0.289 plus E2, which is 0.489. Okay. So if you just created an incorrect assumption, but your incorrect assumption, the magnitude is still correct. Okay. So E is 0.0334, E2 0.2004. Okay. So you're gonna use the positives in our equation. 0.489 meters. Okay, and that's our answer for number 2. Do you have any questions for 1 and 2? Please answer in the Ma'am. Ah, Ma'am, bakit po 12 at 72? Multiply both sides by 72 and 12. You'll get 12E1 minus... Ah, okay. Okay. Tama. Yeah. You'll get 72E1 equals 12E2. Therefore, 72E1 minus 12E2 equals 0. Okay? Nakuha yung 12 and 72 from here. Similar triangles. Okay? I'll blow this up. It looks like this. This is your E1. This is your 12. And then same thing here. Okay? This is your E2, 72. Okay? They're similar triangles because they have the same angle here. Okay? So remember your law of similar triangles. Yeah, yes. Okay, next, paano po nakuha yung E1, E2? Simultaneous equations. You can use your calculator, or you can do it manually. So I have this equation 1. E1 minus E2 equals 0.167. That's equation 1. Equation 2, 72 E1 minus 12 E2 equals 0. So 2 equations, 2 unknowns. That's your math. Try to recall how you solve for simultaneous equations. You can either rewrite E1 as 0.1667 plus E2, and then sub it in equation 2, you'll be able to solve for E2. Okay, so that's doing it manually. Next, try to study your calculator. Okay, for Casio 991ES plus, that's clicking mode equation. Okay, mode 5. to get equation. And then you're gonna choose number 1, which is your a and x plus b and y equals cn. Okay, so that's number 1. And then you're gonna get this table, ABC 1, 2. So these are, a is coefficient of your first variable, b is coefficient of your second variable. So if we write it this way, okay, so this is your equation 1, coefficient of first variable is 1, of second variable is -1, of third variable is 0.167. Here, this is 72, -12, 0. Press enter, you'll get E1, E2. Okay? So that's for your calculator. Try to study it to make solving faster. If you don't want to, again, you can just do it manually as well. Okay? Any other questions? Right. Okay, since no questions, let's have the last topic for leveling, which is reciprocal leveling. So reciprocal leveling is a surveying technique used in leveling across streams, gullies, and other obstructions. So for example, you have a river here and you want to get difference in elevation of these two. So what you do, you're going to set up a leveling rod on both sides and then set up your precise level on one side. You're going to take your readings on both leveling rods, record that. That would be your HA and HB. And then you're going to move your instrument on the other side, take readings on the same leveling rods. You're going to have your HA prime, HB prime. So you're going to get 4 sets of heights, okay? And then this is the equation. So change in H, change in elevation between A and B is HA minus HB plus HA prime minus HB prime over 2. So that's basically HA and mean height of A, because sometimes you're doing a lot of trials. So you're not just taking one reading, so you're just gonna get the average. So mean height of A when instrument is near A, so at this position. And then HB is just reading at here. And then HA prime is when you have your instrument here, reading at A. HB prime is reading at B. Okay, so that's it. So to understand that, let's have an example. Number 3, a reciprocal leveling is observed across a wide river, and the reciprocal level readings were taken between points A and B as follows. So you can imagine the situation is similar to this, your A and B. So these are your readings. With instrument near A, the rod readings on A are the following. Okay. So from that, I can directly get HA. Right? I just have to get the average. So reading, because again, your instrument precise level is at A. Readings on A are this. So 2.283 plus 2.285. The average, so divided by 2, the answer is 2.284. Okay, next. The reciprocal level readings on the other side of the river at point B are the following. So again, I'm going to get the average of this to get HB. So that's 18, 19, 21, 22. And then there's 4 readings, so over 4, you're going to get 3.20. Okay? Oh, so 6, make 6, 2. 618, 619. 3.620. Okay, next part. With the instrument set up near B, so we transfer the instrument now. The rod readings on B are these. Okay, so now that's HB prime. because it's at the other side. Your instrument is at the other side. 478, 476. Okay, again, getting the average, you're gonna get 4.477. And then finally, the rod readings on the opposite side of the river at point A are these. Okay, so once again, I'm just gonna get the average. So it's reading at A, so now it's HA prime. Okay, so HA prime, that was 3.143 plus 3.144. These are 4 readings, so divide by 4, you're gonna get 3.14325. Okay, so that's all of your mean values. Number 1, compute the difference in elevation between A and B with the instrument set up near A. Okay, wait lang. So that means I'm gonna use the readings with the instrument set up near A. Okay, so that means I'm just gonna use this HA minus HB. So that is okay. So 2.284 minus 3.620. Since we're just getting difference in elevation, that's just absolute value. There's no negative for the difference of elevation. And you're supposed to get 1.336 meters. Okay? And so that's the first question. Next, what is the true difference in elevation between A and B? True difference is this equation here. Okay? So true difference. HA minus HB. So we solved for that already. Right? That was 1.336, right? HA minus HB plus HA minus HB. So again, you're gonna use the absolute value. So HA prime, that was 3.14325 minus 4.477. Okay, again, absolute value over 2. And the final answer here would be 1.335 meters. Okay? And then finally, if the elevation at A is 300, what is the elevation at B? So elevation at A is 300. So to get elevation at B, that's just 300. Now here, you have to determine is that plus or minus. Okay? So to figure that out, you have to know which one is at higher elevation. Okay? So upon seeing these, you can just look at one of the measurements from one instrument setup. So, for example, here, right? For your instrument at A, and this is your instrument at A, reading at A is 2.284. At B, it's 3.620. And remember, whichever has the lower reading is at the higher level. Because if you try to imagine, right, the higher your instrument is, the lower the value. So if your instrument is very low, here's the ground, this is higher. Okay? So therefore, A is at higher ground. Okay? And then therefore, B would be less. So to get elevation at B, that's 300 minus 1 point, your difference in H. And that would be 298.665. Okay? And that's it for reciprocal leveling. Do you have any questions? Again, please answer in the chat. Okay. So tomorrow we won't have, yes, the lower reading is the point of higher elevation. Okay, the lesser reading. So on Saturday, you'll have your quiz number 1. Again, open camera, join the Zoom meeting. It's from 1:30 to 3 o'clock p.m. Coverage is everything I've discussed so far. Even your laboratory topics. Also, tomorrow, deadline of fieldwork preliminary data sheet. And then on Saturday is the deadline for your reports. Okay? So also tomorrow we won't have any meeting because we already met yesterday for field. Okay? So you don't have any more questions? Right. So since you don't have any more questions, see you on Saturday. You may go. Goodbye, class.
Goodbye po, ma'am.
Thank you po, ma'am.
Thank you, ma'am.
Thank you po, ma'am.
I'll upload this video later. Okay, thank you.